Okay, this is 4.6a of algebra. So a relation is a pairing of numbers in one set. This will make sense in a second, but called the domain, with numbers in another set called the range. So we've worked with this before, okay? Just like another word you could say for the domain is the input, the stuff that you put in. And the range is the stuff that you get out. And usually we express a relation as an ordered pair, x comma y. So let's look at an example. Okay, so each of these are relations. So they give us 4 points here. The x, that's our domain. All these first numbers that are circled now, those are our domain. So you can see they list it out in brackets right here. So the domain is, and we write it out in order, and we only need to write the numbers once, right? This is like a set. We only write the number once. So it's -2, 0, 4, and 5. And then the second number, my y, that's my range. And again, we write that out in set notation. We only write it once. So you can see that I only wrote 2.5 once. So then we can use a mapping diagram. So we put the domain in a circle, we put the range in a circle, and we draw arrows for which ones go together. So -2 goes to 0.5, 0 goes to 2.5, and 5 goes to 2.5. So there's 2 arrows there. It is a function if there's only one arrow coming from each of the domains. Remember, -2 needs to always go with the same number. So there's only one arrow. It always goes with 0.5. 0, there's always one arrow. It only goes to 2.5. It's okay that 5 goes with 2.5 as long as every single time 5 goes with 2.5. So if you look at the one on the right, if we look at our mapping picture or mapping diagram here, you can see that 6 goes with 4 and 6 goes with 5. So this is not a function. Not a function because 6 needs to always go to the same number. It can't go to 5 and go to 4. So let's draw our own mapping functions. So D for, oh, that does not look like D. D for domain. So I've got 4.2, 5, and 7. And for my range, I've got 0, 1.5, 2.2, and 4.8. I'll use a different color and I'll draw my arrows. So 4.2 goes to 1.5, 5 goes to 2.2, 7 goes to 4.8, and 4.2 goes to 0. This is not a function. Not a function because sometimes 4.2 goes to 0 and sometimes 4.2 goes to 1.5. Sorry, they also wanted me to identify the domain, so I'll write these out as a set as well. So we've got 4.2, 5, and 7. And for my range, I've got 0, 1.5, 2.2, and 4.8. Okay, let's do that one more time. So my domain is -1, -2, 4, and 7. Remember, domain is the x values. My range is -7, -4, 1, and 2. And then I'll do a mapping diagram. So my domain, I need a little bit more room. This is my domain. -1, -2, 4, and 7. Going over to my range, -7, -4, 1, and 2. And I'll draw on my arrows. So -1 goes to 1. -2 goes to 2. 4 goes to -4. and 7 goes to -7. So this is a function because every value in the domain, every x, only goes to one y. Okay, another way to check if something is a function is using the vertical line test. So we use this one when we're looking at graphs, okay? We're not going to use it when we're looking just at a list of points. We'll use it when we're looking at graphs. So if you can draw a vertical line, verticals up and down, if you can draw a vertical line and it only goes through one point, then it's a function. So here, see here in the first graph, this line here goes through 2 points. So this is not a function. Whereas over here in B, any point I choose, any spot I choose to draw a line, it's only going to go through one spot on my graph. So that is a function. So we've got 2 examples down here I'll graph. 4, 2, 1, 2, 0, 1, -2, 2, and 3, 3. When you're using points, I'm going to go through and I'm going to just make sure I go through every point. So, whoops, let's see if I could draw a straight line. That only goes through 1 point. That 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 goes through 1 point. So this is a function. Now I'll graph my other one. 0, 2, 1, -1, -1, 4, 0, -3, and 2, 1. So again, I'm going to draw a line through everything, every dot. So, whoops. That one just goes through 1. Problem, that goes through 2. This is not a function. I can already stop right there. Because what this means is 0 goes to 2 here and 0 goes to -3 here. That's not okay. It needs to be going to the same number every time. Okay. And when we know something's a function, instead of just writing it as a regular equation, like there, we can write it in what we call function notation. So instead of our y, we use this f with the parentheses and an x in it, which we say it out loud, we read it as f of x. So these are the exact same equations. This one right here, though, is just in function notation. We put the f of x instead of the y. So when we're evaluating a function, when it's in function notation, so this is something like our equation looks like. W of x is equal to 250x. So this is the number of words, W of x, you can read in x minutes. We want to know how many words can you read in 8 minutes. So you plug in 8 for x. Now I've got 2 locations to plug in 8. I plug it in here, and I plug it in over here. Function notation is nice because it tells us what number we're plugging in. And then I'd simplify and we get 2,000. So W of 8 is equal to 2,000. You don't do anything with this over here. That stays like that. You don't have to divide by 8. That stays there. This is just telling me this is the number of words that you can read in 8 minutes. It's 2,000. So we want to know how many words can you read in 6 minutes. So here's our function again. And so I'm going to plug in 6 for x. So this whole thing right here is telling me the number of words I can read in 6 minutes is 250 times 6. And then I can simplify that. So the number of words I can read in 6 minutes is 1,500. And I'm done there. So if I want to put that in words, you can read 1,500 words in 6 minutes. And there's your homework.